we started the first chapter, and um, after defining the first and the second law, we looked into the applications of thermodynamics. Are you with me?
Yes, sir.
Yes, sir.
All right. So we looked into applications ranging from our daily commodities, such as fan fitted within your laptop, your refrigerators, microwaves, to applications on a very huge scale, such as power plants, aircraft engines, and internal combustion engines. These would be the applications, as I've mentioned earlier also in the introductory class, that in this course, you would essentially be looking at the principles that help us define equations of thermodynamic interactions, and you will apply those equations on simple systems or components. For example, power plant basically has four basic components: pump, compressor, condenser, and a turbine. You will apply these equations later on each of these components individually, and you will analyze the efficiency of each of the component. But when you move on towards thermodynamics 2, the goal would be to apply these principles on an overall complex system and assess the efficiency of that system. All right. So no more individual components. You will directly move on towards a complicated system. You will divide those systems into components that you have learned in this course, and you will assess the complex system as a whole in thermodynamics too. So you'll be basically moving towards the applications. Clear? All right. The basics that we'll be touching today, most of you would be familiar with it because it is related to units, dimensions, dimensional homogeneity, which you have probably covered in your high school physics. But we'll try to look at the units with some different perspective today. Slightly different perspective. Information might be the same, but the perspective is the important thing that I'll highlight. All right. So we'll begin with units. The first thing when we come to units is the dimensions. What do you understand by the term dimension? Anybody else? What is a dimension? Are you new to the class? Acha, chalo. With respect to units, if you recall your high school physics, what is a dimension? Dimension is basically any physical quantity which can be characterized. A physical quantity that you need to characterize, you have to give it a name, and that name basically falls into the category of dimensions. For instance, length, temperature, mass, time. Clear? If this is defined as dimension, then what is units? Agreed. So once you have defined the dimension that you are referring to, units basically refer to the magnitude of that dimension. For example, if I ask you, for those sitting in the face-to-face class, what is your age? Months? Years. You have to specify that. Although I unconsciously know I can relate your physical texture with the number of years, but that is not inherently possible in all of the circumstances. So if you don't specify the extent of the magnitude, or if you don't specify the magnitude of a dimension, you are basically lost. All right? Is it clear? So units are probably more important as compared to the dimension itself, because without specifying the units, you are probably lost with numbers. You just have a number without any clue what that exactly means. Clear? All right. So the magnitudes assigned to dimensions are called units, and they are basically two uh, important or well-known systems that have been adopted throughout the world. with regards to the units. Sorry, MK system, and the SI system, and the English system. All right. Now, it was in 1954 that few of the basic dimensions, six of the basic dimensions, and the corresponding units were assigned in the SI system, or were brought under the category of SI system. There was a conference on weights and measures, which is the conference which decides about the weights, the dimensions and the units. So it was in 1954 that these six of these dimensions and units shown to the extreme right top corner of the screen: length, mass, time, temperature, electric current, and amount of light. These six were included in the SI system. All right. And it was not until 1970s that the amount of matter, which is mole, which is the seventh dimension, which was included in this system. All right. Now, this SI system is a very reasonable, relatable system. I'll come to it in a few minutes time. Before, except for US. In 1970s, US tried to shift towards the SI system. Before 1970s, uh, almost all of the world had adopted this SI system. Now, once the system has been adopted and US was lagging behind, the industries which had to compete in the global market, they intentionally or they were forcefully compelled to adopt SI system. I am referring to the industries which had to compete in the global market. Auto manufacturers, if they have to compete in the global market, they have to come to a system where they can compete with the products available in the same dimensions. Clear? But even up till majority of the local industries in US, they don't follow the SI system, they follow the English system. This basically highlights the need of having an understanding of the English system. Why? Because if I am moving abroad to US and I want to compete in that market, I need to have an understanding of how they measure things or how they refer to objects in terms of dimension and units. For instance, uh, if I ask you what is your weight, 94, the automatic assumption that would come into my mind, like that which come in my mind when you said 21 years or 20, that you have 94 kgs. All right. So you have already living in this system, having educated within the system, you have an unconscious understanding of the weight of a human body in kilograms and the physical appearance. But what if someone comes from US and you ask him his weight and he says 140 pounds? For a moment or so, you will be confused. अच्छा इसको convert करें, इतना होगा, इतना ही होता है. So you will be lost for a minute because you are not used to that system. The same is the case why I have selected few of the dimensions in their conversion in the English system. The reason being, if some of you or most of you happen to go to US and compete in their market, and somebody asks you that if I have dia rod length of 6 feet and I want to mold it into something, or I want to do some machining operation onto it, uh, what are the operations should I opt for in the beginning? Or I want to reduce the dia, I want to reshape it, whatever the manufacturing process I want to do to reduce the dia to, let's say, 0.75 inches. Now, instead of concentrating on the actual process, you would automatically be working towards the change in dimensions. 0.5 इंच कहा था, तो 0.5 इंच कितने mm के बराबर होता है? 6 feet कहा था, कितने meters के बराबर होता है? Instead of focusing on the actual problem, you will be converting the dimensions in your head. All right. So since US is the biggest market or one of the biggest market, you should have a basic understanding of the commonly used dimensions in their system. That is why the English systems or the dimensions related to English system are included in this course, in the initial course. These dimensions would initially be very, very simple to understand, very simple to convert. But as you move ahead and you have a problem suddenly coming in the English system, your mind would be facing confusion. You would be focusing on the dimensions and the units instead of focusing on the practical problem itself. Clear? The need why we have the English system included in a course. Now, moving on to the SI system. SI system is a more relatable, more logical system which has been developed on decimal basis. For instance, I say that uh, milligrams. What do I understand by milligrams? Thousandth of a gram. Milliliter. So the common thing is, if I attach milli with any, milli as a prefix with any unit, I already have an understanding of that. Very convenient. On the other hand, if I say how many inches are there in a foot? 1000? 12 inches. Based on the same logic, how many quarters are there in a gallon? 12, 3. So there are 4 quarters in a gallon, but there is no logical relationship between the two different dimensions that I have. That makes the simple system more complicated. Clear? But the only need that you should have an understanding of the system, or you should memorize the conversions, is basically the one of the largest market which is there in US. If you happen to go there, you should be familiar with the system. Clear enough? Ji. Why is that? ना करें ना करें At, हाँ ऐसा सिस्टम ज्यादा कन्वीनियंट है. It is always I mean, if the rest of the world is following an SI system, why is that US doesn't shift to the SI system? Why do you think is the reason? Or what do you think is the reason? No. It's always difficult to resist a change. If you are used to a system, uh, you have borrowed your equipment, which basically satisfies the English system. You will not put an effort to replace all your system and have a new infrastructure which is based on SI system. Why would I do that? Unless and until there is a threat to my business or my business is not running, I'll not opt for that. All right. Moving on. Again, the SI in the SI system, the 6 dimensions that we have defined, or the 7 dimensions that we have defined along with the unit, these are the primary units or the fundamental dimensions, and all the dimensions and units derived from these primary dimensions are basically known as secondary dimensions or derived dimensions. Clear enough? Now, moving on to the right hand side, top corner, you have some prefixes written with the SI units, just to highlight the fact that whenever you have mega ohms, megapascal, milliliters, or one thing is convenient, that the prefix is already known to you if you are familiar with the system. Clear? The second thing, the conversions on top. 1 pound mass is equals to 1 pound mass is equals to 0.45 kgs roughly. 1 foot is equal to 0.3 meters roughly. These conversions should be with you in your heart. All right. You should be familiar with these conversions. I mean, there is no logic behind it. You need to memorize them. Clear enough? Moving on towards the force, which is again a very commonly used in the SI system. We say that 1 Newton is equivalent to a body having a mass of 1 kg accelerated through the acceleration of 1 meter per second square. Clear? In the English system, you have a body of 32.174 pound mass accelerated through 1 feet per second square, which gives you 1 pound force. Clear enough? Any doubt in this? All right. And roughly 1 pound force is equivalent to about 4.4 newtons. All right. Just to have an understanding of the magnitude of the two. Moving on now, within thermodynamics or the other courses that you'll take, It is very rare that you express the dimensions in primary units. It is very, very rare. For example, work is what? Force into distance is the energy. You would see very often that energy in thermodynamics and other courses is expressed in terms of joules or more oftenly kilojoules. That is more convenient. All right. So 1 kilojoule or joule is the most commonly used expression for energy. There are two other terms that are very oftenly encountered. I have consumed 4 calories. आज मैं इतना भागा कि मैंने जो है वो 300 कैलोरी बर्न कर दी. What is a calorie? The physical understanding of calorie is the amount of energy which is required to raise the temperature of 1 gram of water by or from 14.5 degrees centigrade to 15.5 degrees centigrade. So if you raise the temperature of water having 1 gram in weight from 14.5 degrees to 15.5 degrees centigrade, that would basically be equivalent to the energy expressed as 1 calorie. Clear? ये definitions दी हुई है book में. You don't need to write them. 1 BTU, again BTU is very commonly used unit for energy, British thermal unit. 1 BTU is the English system unit, and it is expressed as the amount of energy required to raise the temperature of 1 pound mass of water from 68 Fahrenheit by 1 degree. Clear? Clear enough? All right. Moving on, what is dimensional homogeneity? Dimensional homogeneity क्या होती है? Physics में पढ़ी होगी.
Sir, the left side पे dimensions हैं और right side पे dimensions.
सर एक इक्वेशन की दोनों साइड बराबर प्रूफ होती है डायमेंशन से.
हाँ. Both sides of the equations should ultimately have similar units. Clear? Now, for the secondary units, at times you are asked to express an answer in secondary units, and the data is essentially given in primary units. For example, आपको ये कह दिया कि I have a ball in my hand which is at a height of, let's say, 5 meters from the ground. I release the ball from my hand. As soon or just before it hits the ground, what is the energy that is being carried by that ball? Clear? Write your answer in newtons or joules. Now, the data given to you is in primary units. The data asked from you is essentially in secondary units. All right. So in those conditions, you basically use unity conversions, which are nothing but the relationship between the primary and the secondary units. For instance, 1 Newton is equivalent to kg meter per second square. Now, often you can have time given in seconds, mass given in kgs, dimension of length given in meters. This is the data which is given to you. The required data is normally asked in newtons. If I have been asked to give my answer in Newton, I need to have this sort of conversion with me. I should know that 1 Newton is equal to itna kg per meter second square. All right. Similarly, 1 pound force is equal to 32.4 pound mass per feet per second square. Clear? These conversions, although look very simple, you have been using them very frequently, but as you go ahead, this would become more complicated. So you should know the conversions by heart or the relationship by heart. Now, there are a few things that needs to be discussed on this slide. First thing is it is written on the box of cereal that net weight is 454 grams. Is there any problem with this statement? So you should be very familiar that you are referring to mass and not the weight. Weight is basically the force of gravity acting on that mass. And the unity conversion, if I know that the weight is, let's say, 454 grams, and I need to find out the weight of that material, I'll multiply it with the value of gravity, and I use these two unity conversions to find out the actual weight in newtons. Clear? Now, there's one more thing. I have used the value of gravity as 9.81. Is it correct? क्यों? You have come up with a point that I could have never thought of. the value of G is essentially 9.807, something like that, at sea level. Below sea level, 4,500 meters below sea level to 30,000 meters above sea level, the value of G changes, but the change in the value of G is less than 1%. So if the change for all the practical reasons, the practical applications is negligible, and if you incorporate that value into any equation, the error in the answer would also be negligible. All right. That's why we assume the value of gravity to be 9.81. But as you go beyond that, about 100,000 meters, this value could drop down to 9.7. All right. So for all the practical reasons, you have assumed this value to be 9.81. Clear enough? Because the effect is negligible. Is it clear? Moving on towards systems and control volumes. Now, any idea what a system is? Any vague idea what a system is? In
Sir,
terms of
the thing is,
thermodynamics, जी क्या है?
सर जिस चीज के अंदर कोई ऑपरेशन परफॉर्म हो रहा हो
जिस चीज के अंदर कोई ऑपरेशन परफॉर्म हो रहा हो, somewhat correct. System is basically the quantity of matter region which is chosen for the study. For example, I want to know how much heat is generated within this room. Everything which is present within this room at that given moment becomes my system. Everything outside this room becomes my surroundings, and the boundary separating the two would be the boundary of the system. Clear? So surroundings is the mass or region outside the system that you have chosen for the study, and the boundary is basically the real or imaginary surface which separates the system from the surroundings. The boundary is normally of negligible thickness. All right. So if I have this space which is of interest to me, I'll say that this space is my system, the black line is my boundary, and all the white region around that system is my surrounding. Clear enough? Moving on, the boundary of system can be fixed or movable. For example, I have gas stored within this piston cylinder having this much mass and this much volume, and I say that I am interested in the behavior of the gas. Do I have fixed boundary or movable boundary for the system that I have defined? Gas, which is slightly pinkish in color, is my system. Do I have a fixed boundary or a movable boundary? Those who are online, have you got the question?
yes sir
तो क्या जवाब है?
sir movable
Sir,
boundary
repeat the question, please.
Movable boundary है.
Yes, sir.
yes sir
All right. If I say the left hand side of the cylinder, the right hand side of the cylinder, and the bottom of the cylinder, are they moving or fixed? So
So they
these
are
boundaries
fixed.
are basically fixed, and this is the boundary which is a moving boundary. It can move. I can have both the boundaries present within the same system. Clear enough?
Yes, sir.
All right. Now, the system itself can be defined in terms of open system and closed system. All right, I know. Anyways, so there are two kinds of system that we'll be discussing: the open system and the closed system. A closed system is a system. Now you know what a system is. It has further restriction that no mass can enter into the system or can get out of the system. Once you have defined your system, if you have defined your system in a way that no mass can come into the system or move out of the system, your system is basically a closed system. And closed system, as it is written on the slide, is also known as control mass system. It means you have contained the mass of the system and now you are doing the analysis on the system. Clear enough? However, the energy interactions with the surroundings can still take place. Clear enough? Any doubt? All right. Open system, on the other hand, is a system which is known as control volume, and it is a properly selected region in space where mass can flow into the system or mass can flow out of the system. So the mass interaction with the system is possible in control volumes. However, it is not possible in controlled mass systems or closed systems. For example, compressor, turbine, nozzles. You're familiar with compressors, turbines, or nozzles? Nozzles should be the easiest one to be familiar with. साइकिल में हवा तो भरी होगी कभी ना कभी. So nozzle is such that you have two openings. One, the cross-sectional area is more as compared to the other. From one side, the mass is coming into the system. The other side, mass is going out of the system. So one thing is, if I have defined this in 2D as my space of interest, I could safely say that this is a control volume. And control volume is defined by control surfaces. These surfaces, again, could be real and imaginary, or both. As in the case of nozzle, you have these black lines indicating that you have real surfaces, and the dotted line at the entrance and exit refers to imaginary surfaces. Clear? Now, the boundaries of a control volume, as it is mentioned, could be real or imaginary. They could still be, as in the example shown to the extreme right corner of the image of the slide. You have this boundary which is still moving. There is fluid coming into the cylinder. So that system which you have defined by this dotted line cannot be a controlled mass system because the mass is moving into the system. Clear enough? Do I have any real boundaries in the real surfaces in the system or imaginary surfaces? System B. Control surfaces, are the surfaces imaginary or real? Is there any imaginary surface? The opening
Yes,
is
sir.
basically the imaginary
Opening.
surface.
No, no, sir. Yes, sir.
जी बिल्कुल, जी बिल्कुल, बिल्कुल. If I'll not have this, if I'll have it closed, I'll essentially have a closed system. All right? Clear enough? So let's say I have a geyser at home, and there's cold water which is at 25 degrees coming into that geyser, and I want hot water moving out of the system towards my bathroom. I want it to be at 32 degrees. Now I want to analyze that how much heat should be provided to that geyser so that the cold water which is coming at 25 degrees centigrade should leave the system at 32 degrees centigrade. Should I assume my geyser to be an open system or a closed system?
Open system.
Any idea? क्या ख्याल है?
Open system.
जी?
Open system.
Control surface?
Open system, sir. Open system, sir.
Open system.
Just a minute. सिस्टम क्या होगा मेरे भाई? कंट्रोल सरफेस सिस्टम है. Anyways, control volume. So you will have a control volume defined as the geyser and one inlet which is of the cold water and the one outlet which is of the hot water. So there's mass flowing into the system and mass flowing out of the system. Since the two conditions or the only condition for control volume is that mass is allowed within the system or is allowed to leave the system. So you will have it as the control volume. You can still have it as a control mass, a closed system, such that you have all the pipelines enclosed within the system. Geyser bhi aa jaye, dono hot and cold pipelines bhi aa jaye within the system, tank ko bhi le aao within the system. So you have all the components within the system. You can have that as a closed system. ये mass सारा उसी के अंदर circulate कर रहा है. लेकिन that would make your problem much more complicated to analyze. So it is the way you design or the way you define your system, it defines the complexity of your analysis. Clear? The easiest thing was to take it as a control volume. All right. Moving on towards the properties of the system. Property is basically any characteristic of the system. Characteristic क्या होता है किसी सिस्टम का? क्या हो सकता है? Sorry?
खसूसियात.
मैं तर्जुमा करने को नहीं कहा. I mean, can you name any characteristics of a system? Let's say I come to the classroom and it's very cold or it's very hot. How would I say it? Temperature बहुत ज़्यादा है. What is it that is defining the room being very hot or very cold?
Temperature,
Temperature is the
pressure,
characteristic of that system that you're talking about. Similarly, pressure is the characteristic. Characteristics could be temperature, pressure, volume, density, electrical conductivity, thermal conductivity. There could be
entropy,
many properties that define the system, which are the characteristics of the system. Clear? These properties could be intensive or extensive. Intensive means that they are independent of the mass, whereas extensive means that they are dependent upon the mass. For example, if I take this room as my system and I have certain P within the room, certain temperature T within the room, there is certain mass of gas within the room, and if I divide this room into two equal halves, that would mean that the pressure on one half would be P by 2 and the other half P by 2. Yes? No? And what would happen to temperature? Temperature would divide. One half would have T by 2 temperature, the other would have T by 2. Yes? हो जाएगा इधर भी उधर भी. So pressure and temperature would essentially be the same in both the halves. They are independent of the mass present within this room. Clear? Similarly, if I talk about mass, what would happen to mass? So it is essentially dependent upon the mass. It's an extensive property. All the intensive properties such as pressure, temperature, density, which are independent of mass, they are expressed as small letters, with the exception of pressure and temperature. सिवाय pressure and temperature के, इनको capital letters में लिखा जाता है. All intensive properties are expressed in terms of small letters. Clear enough? On the contrary, all the extensive properties, with the exception of mass, are expressed in capital letters. Volume, कैसे लिखते हो? छोटा भी लिखते हो, बड़ा लिखते हो? So volume is an extensive property expressed in capital letters. The abbreviation is expressed in capital letters. All the extensive properties are expressed as capital letters with the exception of mass. Clear enough? Same example is given on to the right hand side of the screen. Specific properties. Specific properties are extensive properties which are expressed per unit mass. That means any extensive property which is dependent upon mass, if you divide it by the mass, it would become independent of the mass. Clear? And it would actually convert into an intensive property. For instance, I have volume. Volume is an extensive property which is dependent upon mass. But if I divide it by the mass, which is volume per unit mass, it is expressed as specific volume, which is an intensive property. Clear enough? Similarly, energy. Energy is dependent upon mass. It's an extensive property. But if I say specific energy is energy per unit mass, which is expressed as small e. Clear enough? All right.